but we have a geometry final to get ready for. All right, you guys, in this 9-6 stuff, this whole idea of solving means that you have to have all the side lengths and all the angle measures. And so like for number 13, I know that I need to find out how long side AB is. Angle C is 90 degrees. I'm gonna also have to find out the measure of angle A. If you haven't done all three of these things, and the measure of angle B, if you haven't done all three of these things on your paper, you know you've got some things to work out while I go on with this one. The first thing I'm gonna do with number 13 is I'm gonna find out the length of the hypotenuse. I'm gonna put a C there. 9 squared plus 12 squared equals C squared. That's 81 and 144. What does that add to, you guys? 225. So that makes C, when I take the square root, that should be 15, right? Okay, so side AB is 15. I've got that. Now, in order for us to find the angle measures, we have to use trig ratios. We have to use sine or cosine or something. I'm gonna put a little a at angle A. Now, I'm gonna do opposite over adjacent to find angle A. And I'm gonna say that opposite over adjacent is tangent. The tangent of angle A is 12 over 9. And so then doing that, I have to go and say then the tan inverse on 12/9 is going to give us that angle A. When I do tan inverse, and if you found some other way to do this, like you used a different trig ratio, we should still be getting the same angle. I'm getting A is about 53 degrees. Measure of angle A is about 53 degrees. So I go over here and I say, all right, A, I can put in a 53 degrees now. Now, in order to find measure of angle B, I think measure of angle B is easy enough by saying 90 minus 53. It's the other angle in there. And 90 minus 53 is gonna be what? 37 degrees. So you have to have all the side lengths and all the angles to solve a triangle. So I've got everything I was missing. Once I knew this angle was 53, 180 minus 90 leaves me with 90 minus this to get my 37. So all kinds of stuff going on in there. 14. What are we missing in 14? Structure this, if you don't have it on your paper this way, put it there so I can see all your measures. I need the length of ED. I need the measure of angle E. I need the measure of angle D. You'll see that set up like that on your exam too, just a place to put your answers. First things first, I'm gonna find that hypotenuse. 8 squared plus 14 squared equals C squared. That's gonna be 64 plus, I don't remember. 64 plus 196 is C squared. What's the sum? 260. What's the square root of 260? You guys all with Harry on that? It's about 16.1. Okay, I'm gonna go here. It's on my drawing. Now, if I wanna go get the, I'm gonna do this next to it. If I wanna get the little angle D, I'm gonna use what was given, opposite adjacent again. I don't know, I'm just getting, well, I see, these problems were set up the same. The tangent of angle D is gonna be 8 over 14. Opposite over adjacent, yeah, that's right. So the tangent, the inverse tangent of 8/14 is gonna give me angle D. So when I do inverse tangent on 8/14, I'm getting, that's about 30 degrees, 29.7. So D is about 30 degrees. And if that's the case then, D is about 30, then angle B, or I'm sorry, angle E is gonna be 90 minus 30. 90 minus 30 is gonna leave us with 60 degrees for angle E. You gotta have all the side lengths and all the angle measures to finish those problems up. All side lengths, all angles. When we go to problem 15, in the case of 15 now, I'm missing YZ. I need the measure of angle X, and I need the measure of angle Z. Now YZ is a leg, so 3 squared plus B squared equals 9 squared. It's not a missing hypotenuse, this time it's a missing leg. So 9 and 81 here. When I take 9 away from both sides, I get B squared is 72. Let's just subtract 9. When I take the square root of both sides, the square root of 72 is going to leave me with that side length as approximately 8.5. approximately 8.5. Now I have to go in and use my trig to figure out the angle measures. I'm going to drop in a little x right here. Bless you. Drop in a little x on angle x to find that. When I look at what was given, I have the hypotenuse and the adjacent. So I'm actually going to take this one and do the cosine of x is equal to cosine, adjacent over hypotenuse, 3/9. That's a third. The inverse cosine of 3/9 is going to give us that angle x. When I do the inverse cosine of 3/9, I get angle x is about 71 degrees. It's 70.5. You could, as long as you still got the same angle measure. Yep, you could. I like to use the, sorry about that. I like to use the given measures in case I made a mistake, but you can still get at it, you know, if you don't use the same one I do. So if that angle's 71, this other angle Z is going to be 90 minus 71, that's going to be 19 degrees. We already have a 90-degree angle, so these two have to add to 90 as well. So what do we got? Measure of angle X is 71. Measure of angle Z is 90 minus 71, left us at 19. Number 16, I'm missing in 16. I need a side length, HJ, that's a leg. I need angle G, measure of angle G, and I need the measure of angle H. Again, set these up so I can see your three answers because it's just going to remind you like, oh yeah, I got to go get all parts. I remember back on this test that a lot of you guys just like came up with a part and left some other stuff blank, so your highlights were things that I still needed you to calculate. Missing leg, 14 squared plus b squared equals 16 squared. If I find out what 14 squared is and subtract 16, I'm sorry, if I find out what 16 squared is and subtract 14 squared, this should get me to b squared is 60. If you've got more on your page, fantastic. I think 14 squared is what, 256? And then 16 squared, 14 squared is what? 196. What do you get for 16 squared? That's the 256. The difference is, there we go. When I take the square root of both sides, that side length, that leg is going to be the square root of 60. It's going to be approximately 7.7. That leg is about 7.7. And then I don't care which angle you go in at. I'm going to go grab little g here. I've got an adjacent. I've got a hypotenuse. If you grabbed angle J first, you'll see what it is in a minute. Okay, so this was 7.7. I'm in here. Let me just finish this one up over here. G, adjacent and hypotenuse. The cosine of G is 14/16. So the cosine inverse of 14/16 is going to give us angle G. And when I go into my calculator for that, cosine inverse on 14/16, I'm getting that that's about 29 degrees. If G is 29 degrees, 90 minus 29 degrees is going to leave me with 61 degrees for J. The two angles that are there have to add to 90. If your rounding was off a little bit, so be it, because if you tackled it a different way, we're going to be close, but may not be exact. 17. Okay, now 17 is different because we are missing two side lengths. We're missing KL, we're missing ML. We're also missing the measure of angle K. Now in this one, as far as I'm concerned, the measure of angle K is the easiest one to get. 90 minus 40 is going to leave me with 50 degrees for right there. Got to add to 180. 90 minus this 40 leaves me with 50 degrees over here. Now, how do I go find these side lengths? Well, now I've got to put some letters there. Let me put a little k right here, just because it's side KL. I don't know. I'm going to go take this measure, this angle right here, 40 degrees. Think about how K is opposite. And the hypotenuse is given, it's 8. And so for this one, if I do a, what do I got? Opposite and hypotenuse. If I do a sine of 40 degrees, that's going to be equal to K over 8. To undo divide by 8, all I've got to do is take the sine of 40 degrees, not 4, 40, and multiply it by 8. And when I do that, I get K is approximately 5.1. That's this side length now, 5.1. Now, I can handle this next part a couple different ways. So that's side KL, 5.1. And I'm just going to use Pythagorean theorem to find this. I'm going to call that one little m. Little m squared plus 5.1 squared equals 8 squared. So I'm going to use Pythagorean theorem to find my last side length. Oops. 5.1 to the second. 26.01. That equals 64. 64 minus 26.01. M squared is 37.99. To figure out what M is, I've got to take the square root, and the square root of 37.99 is about 6.2. That M is the letter I used for my side length ML. 6.2 here. I see pretty much everybody doing something on your paper, which means that this solving maybe didn't go as far as you needed to take it. That's okay, just get there now. Number 18, I'm missing angle T, the measure of angle T. That's going to be my easiest one. Let me grab that in a second. Put that at the top of the list because I know I can do that easily. I'm missing side length RS, and I'm missing hypotenuse RT. The measure of angle T is going to be 90 minus 57. That's going to be 33 degrees. 33. I think, yeah? 90 minus 57? Yeah. All right, now, if I put let me put a little S right here for this side length RS. If I use this 57 degree angle, I've got an opposite and adjacent. So to find that angle, or I'm sorry, to find that side length S, I can say opposite and adjacent, TOA. The tangent of 57 is equal to 15 over S. And if you guys remember right, when our variable's in the denominator, we just switch it. Algebra will get us to that. 15 divided by the tangent of 57 is going to be that side length. And I'm getting about 9.7 for that one. 9.7 over here. RS about 9.7. Now, since I'm approximating, when I go to find this hypotenuse right here, nice. Oh, that's everything.
I did.
Beautiful.
I didn't pre-sign it for you, but I'll get there.
Thanks. All right, shoot, where was I at? 9.7. Now I'm missing just the hypotenuse. I'm going to put this one right here. Let's go 9.7 squared plus 15 squared, good old Pythagorean theorem, equals C squared. I'm getting 319.09 is C squared. Oops. When I take the square root of that, I'm getting about 17.9. That makes sense because the hypotenuse is the longest side, 17.9. A lot going on in these problems. This was one of the longest parts of this whole review because of the 6 solving. So, and again, I'm noticing everybody's doing a little more than you had. Now let's take a look at number 23. Oh shoot, I wanted to draw that better than what it is. The angle between the bottom of a fence and the top of a tree. Okay, here we go. I'm gonna draw this, you guys. I can kind of see what the drawing is, but here's the tree over here. Here's the tree, here's the fence they're talking about. This is a 75-degree angle right here. This is 4 feet. The base of the fence to the bottom of the tree is 4 feet. And the question is, what's the height of the tree? Put an H there. Related to this 75 degrees, I have opposite and adjacent. Tangent of 75 is going to be equal to H over 4. If I want to undo divide by 4, I'm going to take the tangent of 75 and multiply it by 4. And I'm going to get about 14.9. H is approximately 14.9. Oh, it says round to the nearest foot. The tree's about 15 feet tall. Tree's about 15 feet tall. That drawing was hard to see, but hopefully now that I put it on the page here, you guys got this one.